Hello and a warm welcome to everybody. We would like to wish everyone a good morning, a good afternoon, or a good evening, depending on where you are in the world. My name is Samantha from Safeopedia, and here at Safeopedia, our mission is to support the EH&S professionals, operational folks, and any safety-minded individuals with free safety information, tools, and education. I'd like to extend a huge thank you to those dedicated professionals for the great work they do on a daily basis. Today, we're proud to present Workplace Airborne Particulates and Pathogens. Real risks require real solutions. This Safeopedia webinar is being presented by Blue Sky Global. It is now my pleasure to introduce to you today's presenter, Dr. Michael Seitz. Dr. Michael Seitz is the founder and CEO of Blue Sky Global, based in Houston, Texas. He is the inventor of the Smart Box technology for the Blue Sky air cleaner. Dr. Michael has a PhD from the University of Witwatersrand in Johannesburg, South Africa. In 2001, Dr. Seitz had his first US-based company, Amstar, Surface Technology. With this company, Dr. Seitz became aware that dust collectors were extremely hazardous to maintain, dust, cake, and filter changes. In 2005, he began to develop the blueprint for an entirely new dust collector concept. In 2010, Amstar was acquired by Swiss-headquartered Alstom Power, now part of GE, and Dr. Seitz remained with Alstom as Amstar Global Expansion Director for a further 6 years. In 2016, he resigned and began commercializing his dust collector invention and founded Blue Sky Global, which offers a new approach in dust collection that prioritizes employee safety by limiting their exposure to collected hazardous dust waste. Currently, with a dedicated staff, Dr. Seitz is developing a global network of dealerships and sales representatives aiming at full Blue Sky availability in Americas, Europe, and Asia. I am grateful to have you sit back, relax, and enjoy this presentation. With that, Dr. Seitz, please take it away.
Good morning. I'm sitting in Houston, Texas, where we've got lovely blue skies. The topic today is air quality, specifically in the workplace. And right now, actually, it also pertains very strongly to the air quality in enclosed spaces where we go shopping, pharmacies, doctors' offices. So the coronavirus has brought a whole new level of applicability to the Blue Sky technology. I'm not going to touch on that much today, but during the question and answer session, it may be interesting to discuss the potential of implementing Blue Sky laminar flow systems to reduce the incidence or the potential spread of coronavirus through aerosols, fine particulates in the air. Okay, so the first slide essentially shows exactly a dramatic example, but exactly what we're talking about, where we have the difference, and I think most of the audience, you are in safety already. It's a little strange, I'm talking with very little feedback, so you'll have to excuse me. I'm talking at my computer screen. The situation depicted in this first picture is of a bagging facility, and the people are wearing PPE of some or other description, face masks in this case. And so there is the PPE side of safety, of course, wearing gloves, hearing protection, face masks, appropriate clothing. And then there is what I consider the more important side of modern day safety, which is environmental control. In other words, if you can make a place safer to work, then the PPE becomes secondary. And that's an ideal situation. So let me take a non-air example. If you can have a factory where the noises are not too loud, then the use of hearing protection is still important, but you can be safer in that work environment should an earplug fall out, or should somebody not even be wearing one because they may be hot or have an ear infection. And so environmental controls is a way that in the hierarchy of things that would be preferable, and a way that we can protect people intrinsically. The area is safe. With air pollutants and fine particles, this protection is late to the game. Why? Because a lot of the dust that we may breathe in and that may actually do damage to our lungs is frankly invisible. In this particular picture that you see, the dust is very visible, and people will taste that dust, they will see it, it'll get in their eyes, and there will be a natural human aversion to it, just like there is an aversion to loud noises, very, very dusty spaces. People go, oh, I'm not going in there. Studies have found that the dust that actually does damage to people is invisible. These are aerosols that are usually below 10 micron in size, and they are breathed into our deep lung. And these are the particulates that actually do damage to people's lungs. How do they do damage? They are breathed in. They go right down deep into the alveoli. They are often non-toxic. So there's a sense of, non-toxic, what's the big deal? But the truth is that these particles get into your lungs. They are foreign bodies, and your body wants to reject them. So you get a bit of an immune response to inhale dust. Mucus starts being formed, and so the body is working very hard to expel those particulates. That's a natural process. If that goes on for a little while, that inflammation process can start the formation of scar tissue. So the danger around inhaling or breathing in airborne particulates is one that develops over time. And so the workplace air quality is actually critical when it comes to particles under 10 microns, because those are the particles that after a period of time will cause the development of scar tissue, and the scar tissue will reduce lung function. So as a person gets older and older, it's a cumulative effect, more and more lung scar tissue forms. And so when you become older, 50, 60, 70, your lung capacity drops a lot, or has dropped a lot, because of your work conditions. And it's at that stage that your quality of life is severely impacted, and you may even develop much more serious lung diseases such as lung cancer, emphysema, hardening of the lung. There's all sorts of fibrosis, terrible things that happen. And it's in your later years that we actually want a higher quality of life, because then we know something, we probably have grandkids, we are retired, we want to enjoy life at that point. And then it's a terrible phase of life to have a reduced lung function. And there's no going to the gym to improve lung function. So when you're out of breath, going to gym is not going to solve that problem. It's a lung function problem. And the high risk is that when you're older as well, if you do develop a flu, bronchitis, a cold, the symptoms are dramatically worse if you've got reduced lung function from some workplace. So as safety conscious community, we have to be aware that what we see in this picture of these men working with the bags, there is a large fraction of dust which is actually going to systematically affect those people. If they are not well fitted, the dust will get round the corners. So the idea is environmental controls. Why? I've already spoken. It's risk reduction. And again, I can't overemphasize, there are toxic dust types where there is an immediate risk to health. You breathe in arsenic dust, you can die right away. The dust that is the dangerous species is the stuff that doesn't necessarily affect you right away. Everyday example is cigarette smoking. People can smoke for years and feel fine, right? A 20-year-old smoking can be an athlete, can be a sportsman, full of energy, blah, 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 continues to smoke, and then the price is really paid later. So risk reduction is which I've got on the left there, is the paramount reason for introducing environmental controls. And then the second benefit, which to me is huge direct benefit is just cleanliness. If you think about it, a facility that is very dusty, that dust does settle, a large proportion of settles, so you've got a dirty environment, you are continuously redisturbing the dust. It smells bad, so any visitors that come in, the whole environment that is under a cloud of dust is always a dirty environment. To the touch, to products, to our clothing, to our hair. So by bringing in environmental controls to control dust, you reduce risk. By the way, risk could also include explosion risks if it's the food industry, or a type of powder, perhaps a metallic powder that has that is flammable. So this risk reduction in health, explosion, and then on the other side is cleanliness, which is a huge benefit just in terms of work practices, clothing, equipment, things like that. Okay, moving on to environmental controls in terms of risk reduction and cleanliness. That is almost common sense. I think it doesn't require a big sales pitch or a huge degree in environmental control to realize reducing risk and cleanliness is an obvious consequence of putting in environmental control for air. But the reality for business or a retail outlet even, or a warehouse which may have a lot of dusty packaging, is cost. It costs money to implement environmental controls. So it would be naive to say that cleanliness and risk reduction is a no-brainer. Let's do it immediately. It is a very, very expensive thing. Okay. So there are two approaches that can be taken. With environmental control, it normally goes to the left process, which is from an accounting perspective, needing to minimize cost. So you want the benefit, but you do not want to have the cost of it. So there's counting the cost. And then there's the value perspective, which is the strategic perspective, where it's like a chess game. You're kind of trying to think about, okay, I've got to spend money. What are my benefits? What are my indirect benefits? And I kind of laid it out over here. So from the cost risk perspective, you've got on the one side, what is the cost financially? Remember, this is a financial perspective. What is the cost of one serious health claim? An example, you may be a factory, or let's take a benign example where you would imagine there's no risk, a big warehouse, and there's packaging that comes in, and it's really covered in a layer of dust. It comes from a paper mill or whatever type of dust it is, and you have a dispatcher who is always receiving dusty packages, handing them, always getting dust in his lung, works in the job for 15, 20 years, and after 25 years develops fibrosis of the lung. What is the cost of that individual's health claim? So that is one cost. Does he request it of the company? Does it end up in lawsuits? In the USA, it could be a lawsuit. It could involve other people in the lawsuit. Maybe other people go, gosh, I have breathing problems too. So that's a future cost of a serious health claim. Then the next one is the cost of an environmental claim. You may be in a factory producing a certain product and there is a byproduct. This is how I ended up designing and developing Blue Sky as an environmental control dust collector. We did metal coatings. And one of the byproducts of our metal coatings, they were fabulous. They were nickel chrome alloys, but one of the byproducts was hexavalent chrome. So as we were spraying these nickel chrome alloys, chrome was being liberated. And so this chrome would be floating in the air, and it would settle on all sorts of things. And sometimes they would go outside or the rain would wash them down. So when they did soil tests, they go, aha, there seems to be some hexavalent chrome in the soil. So immediately you've got Aaron Brockovich type of panic. Oh my goodness, what is going on here? So one serious environmental claim resulting from contaminating the trees, the soil, the water runoffs, whatever, with these fine dust species which leach deep into the soil, the cost of one environmental claim can be quite severe because fine dust has a way of spreading both in water and in the air. And then comes the next one, the cost of remediation. So you could have an environmental claim, maybe the neighbors say, hey, you're putting dust all over us, silica. So there's an environmental claim there of polluting the air, maybe a batch plant or cement batch plant. And then you've got to remediate it. You've got to clean it all up. That can become very, very expensive too. The cost of loss of productivity. If people are working in a dirty environment, struggling with breathing masks where the filters are always getting clogged, remember that first picture? There is actually a cost to people having to deal with dirty environments and PPE. It affects productivity. It affects people's mental state to do a good job. So there is a huge cost of working in a dusty, dirty environment in terms of productivity. And then straight into the next one, lack of wellness. Somebody who's been working 2 or 3 hours in a dusty environment day after day, maybe it's a welder who's got a lot of fume the whole time. Even though we have this huge tolerance to dust, we're not always feeling as well as we could. Whereas if you're working in a clean environment, like we do in offices, often there is a sense of wellness. So there's a cost to not feeling well. And then, of course, there's the cost of disaster. You can have a dust explosion. The classic example is in the food industry. This is a very dramatic example. A company in the sugar industry, Imperial Sugar, they had a huge explosion, destroyed the entire plant. And it was a dust explosion. They had an accumulation of dust over time, settling on all the surfaces. They had an event, and that spread throughout their whole facility. So there could be a disaster, a disastrous event that goes through a plant, which can be the result of dust. So on the left-hand side, we have these risk costs, which are hard to quantify, and the timing is hard to put in there. But all the things on the left, if they do happen, they are expensive. Those are high costs. And on the right-hand side, we've got the immediate verifiable cost of the equipment to mitigate these airborne dust types. So environmental control of removing dust from the air proactively. So on the right-hand side, you have the cost of the equipment and the cost of maintaining it. You've got to service the filters, you've got to keep the machine running, so it's electrical costs, blah, blah, blah. So most accounting processes completely understand the costs on the right. They are present, calculable. You can put them directly into a P&L, and if you bought the equipment, it can be on your balance sheet. The left side is risk management. And this is where health and safety people can raise the alarm bells and say, there is a risk, the law says something, but at the end of the day, the accountants typically have trouble assigning the value of that risk to it. And they seldom do this balance calculation. And of course, the benefits analysis, which is not usually in the accountant's realm, but in the CEO or the operations manager or the human resources divisions of companies, you have healthier people. Clean workspaces means they are proud of their workplace. Housekeeping improves. Imagine a warehouse that's very dirty. The stock taking, the control of everything is all impacted by filth. So by controlling airborne dust, the workplace, pride in the workplace improves. There's a culture of excellence. I did one installation in Holland a couple of years ago of Blue Sky, and the CEO was very, very motivated by the benefits analysis in the beginning about reducing risk, that kind of thing. When I met with him 2 years later and just wanted to know, so as a hindsight analysis, what did he think was the best benefit? He said it was client recognition. He said he had several clients who walked into his facility and said, wow, Tuan, your facility smells clean. We've been in many manufacturing facilities, but your place stands out to us. We're impressed. So client recognition was something that he actually checkmarked as an unexpected major benefit to him. And so he gladly took his people around in the workshops, and they recognized the difference. Risk reduction, of course, we discussed earlier. And then one of the benefits is just compliance. There are a lot of companies right now with the new silica laws out there that are not in compliance yet. So you are running a risk all the time of being out of compliance. It's not easy to sometimes get into compliance because laws change. In the United States, silica being one of them, that has a huge impact. So one of the benefits of putting in environmental control is that a company can go into compliance and nobody has to risk falling afoul of the law, essentially. So those are the returns of investment on putting in the air quality control. So with all that analysis, paralysis done, it's time to go out shopping. And the question really is, people are buying a mousetrap, and there are lots of different devices on the market to catch a mouse. Are all mousetraps born equal? One thing I have to say right now is that a mousetrap, by definition, catches mice. A dust collector, by definition, collects dust. So the actual functionality of 99.9% of dust collectors is good. The question is, are they still equal? And the answer there is that you have to dig a little bit deeper, and it comes down to, once you've caught that mouse, what do we do? So there are many, many devices you can buy that can catch the mouse, but exactly what happens when you've got the mouse or how you set the trap, there's big variations there. So again, to the safety community, I would say, do not just say, we've decided to deal with air quality and we bought a mousetrap, job is done. Not so fast. That mousetrap has to be operated, and once a mouse is caught that is potentially infectious or disgusting, you have to deal with the end game too. So when you go out shopping, these are all the beautiful things you can go out and buy. On the top left is a system for hazardous waste. It's portable on wheels. You got all these nice shiny dust collectors that sit outside factories. They're very big. I want to point out middle bottom, the advertising bottom right always shows that the maintenance, the removing of the filters is always shown with clean filters. There's a reason for that, because once these dust collectors have been in service and collected all the stuff we don't want to breathe in and don't want to have in our lungs, it's now in those filters. It shows you how big those filters are. That is where the concern comes. And that's where Blue Sky came from, because the reality is that dust collector use using the mousetrap, top left, these are heavy, dirty filters. And you look on the ground after a service, you've now got all that fine particulate on the ground. The wind will blow it. It'll be all over people's clothes. Yes, PPE, all those good things, but you have typically, when you're servicing a dust collector, you've contaminated the ground, you've contaminated the air around that, the equipment that lifted people. That's the real world. You can see the bottom left, that is an installation that's been in for a while. That soil, they did a soil test there, is completely contaminated. They are going to have to excavate down a couple of feet there. They're going to have to do something about all those buildings. That's after years and years of work. You can see on the right-hand side bottom, there's a picture of a dust collector that went onto a bridge project. That's in Charlevoix, Michigan. That's a drawbridge. They brought in the dust collectors because they couldn't put the dust in the water. They were sandblasting and repairing that bridge and painting it. So they've brought in the dust collector, and you can see over there how fantastic the real world looks. Okay, so that I was dealing with my previous company with filters that looked like that, but covered in hexavalent chrome. I was dealing with the environment. Oops. Looks like my presentation is having trouble. So let's see, that slide seems to have been killed. Okay, I've lost the slide. Sorry, there's something wrong there. But I was having trouble with the heavy filters and the soil conditions being really, really bad. Okay, so how does a dust collector work? Very, very quickly. Dusty air goes in from one side. On the right-hand side, on the left-hand side, you can see dirty air comes in. It goes through a primary filtration system. In the case of Blue Sky, that would be an F8 or a MERV 14 filtration. It collects the bulk dust, collects on the surface of the filter, and there's normally an online pulse jet cleaning system, something that knocks that accumulated dust that gathers on the surface of the filters, knocks it into a bin below. That bin has to be cleaned out from time to time. So that collector gets opened, that dust is removed. So that's actually another potential point of contamination. Then the air comes out of that primary filtration. In many cases, it then gets vented to atmosphere through the fans, but there's an optional step where you can put it through a HEPA filter. That'll take the ultrafines out. And if you put it through a HEPA filter, you can actually put the air back into the facility. So if there's air conditioning or heating in the winter, if you have a dust collector system, a Blue Sky machine, for example, that has primary filtration to remove the bulk, a secondary filter so that you can return the air back into your facility without any of that fine dust. And then there's suction fans that actually suck it through the system. So in the best dust collector systems, the primary filter and the HEPA filter are both under negative pressure when the system is running. A lot of companies try and put a HEPA filter after the fans on the positive pressure side. That is not a safe way to implement HEPA filtration. Okay, so the mousetrap. On the one hand, on the left, you can see there's a maintenance nightmare. And the smart box, I'm calling it a maintenance dream, little exaggerated there, but the idea of Blue Sky, which is why I got into this business, is we were doing the stuff on the left with hexavalent chrome all over those filters. We had Tyvek on, we really, really worked hard. It sometimes took us 2 days to do a filter change just because of the safety aspect, but there was always a mess. It was impossible to avoid. So the idea was to design a system where the filters are inside a smart box, and when it's time to change the filters, you just pull the dirty part of the dust collector out. The filters are in a box like an inkjet cartridge, and you put a new one in and your dust collector's up and running. So the things that you really want with any dust collector you buy is a very efficient dust collector. It needs to be a dust collector first. Ideally, it should have easy, low cost of installation. It needs to have a good way of collecting the dust, so the storage at the bottom of the unit or within the unit. It needs to have low downtime during servicing. If you're in a facility that has high production rates, every hour or every day that the dust collector is offline for servicing stops production. So you want quick and safe downtime, and ideally you want modular a system so that if you expand your facility, maybe you decide you want to bring in HEPA filtration, that you have the ability to upgrade your dust collector system in the future. And these are all the aspects that I looked at. So this is essentially Blue Sky. You can see this is our inventory in Houston, where every module represents a filtration module, a little bit like RAM in your computer. So depending on the amount of dust or the volume of the air that you have in your facility, you can just add a sectional and grow the size of your dust collector. But everything's contained inside the unit, and there's a smart box inside each unit during the maintenance cycle. So a Blue Sky system is a series of these. I'm just going to scroll down. That's a Blue Sky system standing in a built-up area that was brought in. and there's a blue sky system mounted indoors inside a factory. In this case, it's for coronavirus use, actually. And that is my first part of the presentation. So I think we can open up the floor for some questions.
That was great. It does look like we have some questions rolling in here. Jim asked, a lot of technical jargon is presented when being sold a dust collector. So what information matters and what is just noise?
Okay, so I would say the most important start out questions that anybody should be asking themselves is, for the industry they're in and the dust type, how many room changes are required? If you're in a sandblasting booth and you're actually sandblasting in the booth, the requirement, the legal requirement, or the ideal operational requirement might be 20 times an hour of air change. It could be that you are just in a general fabrication area, you've got some welders, you've got some assemblers, maybe 6 times an hour is enough. So the first question is, how many room changes do I want? You may change your mind in the future. You may say, I don't need as much as I have, or I need more. So that's where the modularity comes in. So the first question would be, how many air changes do I need per hour? It's the same question somebody asks in an air conditioning system. Then the next thing is, what area am I going to put this environmental control into? So if it's a large open hall, that might be a very large area. So once you've determined the size of the contained space that you want to bring in air quality control, you know how many room changes, you know how many, how big the room is. You can now calculate the size of the ventilation system, the fan size. So that's the first important real world question you've got to ask that scales it. The next thing is the dust type and the amount of dust you create. So typically it's, what are you doing and how much of it are you doing? So that gives the loading. And then from the dust type, the type of filtration that is required will automatically be estimated and be able to be determined. So from the person who wants to buy a dust collector, it's how big is the room, how many room changes there are, and what is the dust type and how much do you produce? And then the final question, which I think is critical, and beyond that, you're basically good to go, is do you want to exhaust the air into the environment, or are you going to bring it back into your facility? So those are the most important questions to have ready, written down on a piece of paper when you send out inquiry, to have those there. There will be tons of other small humidity, blah, 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 so it goes, but the big picture questions are the ones that I've mentioned.
Perfect. Diane wants to know, what do you need to know about filters?
Yes, there are so many variations of filters out there. A lot of them are driven by commercial drivers. You know, we have a green one, we have a pink one, we have this, we have that, we have nano this, nano that. At the end of the day, filters are in a way all born equal in that they have a specification assigned to them, which is how do they filter? What is the particle efficiency, the capture efficiency of that filter media? It's usually a MERV rating in the USA. In Europe, it could be an F rating or a HEPA rating. So essentially, it's to know, based on where you're putting the air and what the dust type is, what the classification of the ideal filter is. Second thing is the type of dust will determine how sticky it is. So there might be a small difference. You may have a Teflon coating on there if there's a plasma dust or something to help the shedding of the dust. But essentially, there's a lot of branding around the filters, but the MERV rating and the cleanability are the most important. The calculation of how many filters you need is a different one, but in terms of the actual filter that's chosen, it's mostly determined by the degree of filtration required, either legally or by aspects of whether you want to return the air into your facility or you're just going to dump it into the environment.
Perfect. Colin made a statement. He said, your dust collection responsibility doesn't stop at the machine. So could you expand a little bit on that?
Yes. So the first responsibility is obviously the breathing air of the people, and you can run a lot of tests. Their machines, people check the air quality. The responsibility then is the disposal. So you've caught the mouse. Back to that mousetrap example. You've caught the mouse. The responsibility doesn't stop at catching the mouse. The responsibility continues to removing the mouse, removing the trap, or resetting the trap. And that is where current designs, Blue Sky, or where I addressed the problem is there are fantastic machines out there that capture dust and have wonderful filters in them, but the maintenance of those filters, the removal of those filters, the removal of the dust from the machine is totally not addressed. Their designs are 100 years old. I'm waving my hands when I say 100 years old, but the basic principle is still the same that was employed 100 years ago, which is when the filter is dirty, open a door, open a panel, a man goes in and takes that filter out by hand. It could be a bag, it could be a cartridge, it could be an element, but the principle is still identical. Open a door, yank the filter out. The dust collection bin, detach it, take it off, empty it, dump it, put a new one in. It could be a drum, it could be a bag, whatever. Those principles are 100 years old. And when you're dealing with a dangerous dust, and all dust types are in fact dangerous, that's why you took them out of the air in the first place. These are ultra fine materials. They should not be handled by people. The idea of the smart box is that you don't see that dust. When it's collected and on the filters, you take the smart box out, you put a new one in. It's the inkjet cartridge again. I'm going back to that analogy. The modern printer, you do not mess with ink. You mess with a little plastic pod. You put it in, you put it out. It's expensive, but it's extremely convenient, extremely quick, and safe. You're not going to mess on the carpet. You're not going to mess on your hands. There are going to be no operational issues. So to me, the responsibility of taking the dust out is front and center in terms of the air cleaning, the environmental control, but thereafter there is a giant responsibility to the safety community, operations managers, CEOs to say, once I have caught this stuff, I have a system that is intrinsically safe too. None of my people, none of my service personnel, not a company that is going to open up that dust collector on my premises, get my groundwater contaminated, get my soil contaminated, maybe stop my factory for a day. It's not going to happen. It's going to come out as a smart box.
Right, and it's really important to keep in mind that even once something is removed, dust is such a fine particle that it can really just move throughout the air and you don't even notice it. We have a few more questions. BR would like to know, for protection against COVID-19 in a factory setting, do you have a different setup, or do you expect your filter to do the adequate job?
Okay, so for the COVID-19, we do away with the dust collection part. So Blue Sky, because it was an industrial machine, was originally invented to catch asbestos, hexavalent chrome, silica. When we're dealing with COVID-19, we do not have a big collection volume at the bottom. So the machine is slightly reconfigured, and the filters are then, the primary filters are not as critical anymore. Now the HEPA filtration is the most critical. So where in an industrial setting, the HEPA filtration system is optional, for COVID-19, it is the heart of the machine. And in that role, it is unbelievably good because we're filtering high volumes of air through these very, very high quality HEPA filters en masse. So we're not relying on a small little machine inside every room. That doesn't really work. The Blue Sky machine is creating clean room conditions, laminar flow conditions from the ceiling to the floor, continuously 12 times an hour, removing aerosols from the air and then taking them through the blue sky system for optimal filtration. You can't really filter air any better than taking it through these high quality HEPA filters. In this case, it's on a very large scale. And you can see from the blue sky, this machine here, that's actually a system that was in that has been put together purely to filter out. It's got the main HEPA stage there to take out approximately 20,000 CFM of air, so it can do about 10,000 square feet of cleaning of the air for removing coronaviruses from large spaces, whether that be, you know, a hall, a conference facility, a temporary hospital, a dentist's office, a voting hall, anywhere like that. A Starbucks. On our website, we have a Starbucks in there. Anywhere where people gather, move through the area, continuously circulating, a doctor's waiting room, that's where Blue Sky offers just an amazing solution to continuously replace that air with filtered air and prevent people essentially breathing in somebody else's aerosols.
That is good to know. BR also has a follow-up question. He wants to know, does your system work effectively against the hydrocarbon soot containing exhausts?
So hydrocarbons, I presume he's referring to volatiles, potentially VOCs. These, Blue Sky has these sections. Let me go back to this here. So generically from the outside, they all look the same, but within that unit, there can be carbon, activated carbon. We have a sectional with activated carbon in it, and that's an adsorption process. So it's a huge bed of carbon. That whole bottom section is actually loaded with carbon, and the air is passed through carbon for adsorption of VOCs or any other gaseous smells, essentially. And so we have a first stage of primary filtration where we take out, let me use an example here just to illustrate a good case. We were talking to an aircraft painting company. They sandpaper and then repaint commercial aircraft. They did Air Force One, for example. It's a company called IIC. In their situation, some of those old aircraft paint jobs have hexavalent chrome in the paint, they have chromates. And so when the guys are sandpapering, they're liberating dust that has hexavalent chrome dust. So that would be captured in the primary filtration. Then they have VOCs in the emissions because they're doing painting. So they need carbon activated carbon adsorption. So it goes through that. And then it goes through final stage, HEPA filtration, so that the air goes back into the facility. So in certain painting applications where hexavalent chrome and VOCs are available, you'd have 3 stages: pre-filter, carbon, final filter back into the facility or outside.
Excellent. We have a question from Partha. Is ESP a good option for dust collection?
Electrostatic is very, very good. That's for bulk air. It obviously works that the particles are charged and then they end up on surfaces to collect them. They're normally employed in much larger situations. The maintenance of those systems has the same problem as bag filters, which are also often deployed on these larger projects. So they are 2 different technologies, but in the end, on the maintenance side, they're all troublesome because people have to go in and physically do maintenance of them. So the short answer to electrostatic is it absolutely works, but the ultra fine filtration systems and that for factories and that, really electrostatic is not normally implemented for that. That's normally bulk handling, like at power stations, things like that.
Right, that makes sense. Danilo would like to know, could you give more detail on the reasons why HEPA air filter sections should be placed at the exit ducts and not in the air filter ducts?
So let me go back to that picture quickly. So HEPA filters are designed to take out the ultra fine fraction that the primary filter doesn't catch. If you put it on the outlet side of the fan, which is the high pressure side of it, you have risk of some migratory leakage because it's a positive pressure system. So any installation fault or aging of seals, and remember, the first time it's installed, there's normally not a problem. But realistically, these machines will run for years. And somewhere along the line, during the change out, somebody's not going to put the cover on properly, the rubber seal will leak. And then what you're effectively doing is that you are bleeding out of your system while it's operating contaminated air where the contaminant, which is now normally captured by the HEPA filter, is completely invisible. You cannot see the dust because it's usually below 10 micron. It is not a visible dust size, but it is the dangerous dust. It's the stuff that's getting in your lungs. So there is no warning system to a leaking second stage filter system because what it's capturing is essentially invisible. You may be able to smell it, but in general, it's invisible. So it's not intrinsically safe to put the dangerous filtering end, which is the fine filter end, on the positive side. If you put it before the fan, after the primary filter, it's intrinsically safe. If there is a seal that's broken or something like that, you are still sucking air into the unit and not blowing it out of the unit. So in terms of leakage out of the doors and that of the HEPA filters, it's much better. The service doors, it is much better to have the whole system on the negative side so that you can draw large volumes of air through the HEPA filter and you're not trying to blow air after the fan through the HEPA filter. So it's just intrinsic safety reasons.
Right, that makes sense. We have a question from Pradeep. They'd like to know if you have any reference for standards of selecting dust collectors.
Trying to interpret the question. So what I tried to lay out in this slide here, let me go back here. Hang on, maybe it was a bit further down. This is basically the standards that I would say is you want a very efficient dust collector, which means it's a good design and the air to cloth ratio is the correct one, that the filters clean properly. So you want a good dust collector which is sized correctly, easy low-cost installation. A lot of dust collectors need a slab, things like that. So the installation costs can actually be quite high. In the case of Blue Sky, I mean, we have a special design. We don't need any slab preparation at all. In fact, we can install a dust collector, you can see, in a parking lot in 5 minutes, or it can just be put into a building on wheels. So installation costs can actually be quite high, and they're often overlooked. Then the other one is the dust storage at the bottom. Most dust collectors have drums. I want to show you something here. That's such a good question. I hope this doesn't go unstable on us. This is a brand spanking new, beautiful dust collector at a welding facility. I think it was out in Arizona or somewhere. Can't remember. I took the picture on one of my road trips. You can see the storage facility for this ultrafine welding dust is drums underneath that those dust collectors, and that looks very sensible. There's nothing sensible about that at all. Look at this facility, how crazy this is. Imagine that once those 55-gallon drums are full of welding dust, they will be substantially heavy. So somebody has to go in there with some side of fork, well, you can't drive a forklift back there, but they have to go in with some kind of lifting device and try and yank those drums out from under those machines. That's very poorly thought out to be able to remove drums. Typically with an installation of a dust collector, a slab is poured. But that slab is very hard to access because the drums are, normally up a step or something. So the storage at the bottom is a problem. And after about 1 or 2 drum changes, because they have to be opened up, that ground below will in fact become contaminated. Because as you take those drums off, there's a certain amount of dust that's always going to fall onto the ground as somebody is trying to take the old drum out. It's heavy and awkward. And then they're trying to put a new drum in, and then they're putting the lid back on, and there's a whole lot of spillage. And that's why, after some years, it looks like that on the floor. Because those drums that are being changed out, it is not easy. Do you see what I mean by the slab? Somebody has to get in under that slab and take those out. And those drums are heavy. These ones aren't even on a pallet base. So heaven knows how those guys get them out there. It's just left to somebody to take care of. So that's an example of dust. And then you end up with this. This dust, you may say, oh, that'll never happen at our facility. This happened at a large national company at the back of the building during an inspection that I took of their dust collectors. And they didn't even know it had happened. They had a service crew come in. They actually subcontracted the service. And that's what it looked like after a change. And that dust contained certain carcinogenic species. They were totally unaware of it. Typically what would happen within a day or two, the wind would blow all that rubbish away, or maybe somebody would broom it. It would be washed off into the drainage ditches at the back of this facility. They had absolutely no idea this was going on. So that's the terrifying part of that. So back to my list. So dust storage is safe and the maintenance. Low downtime during servicing. Again, to do the job properly of removing the drums, removing the filters, it can be 1 or 2 days of downtime for the facility, maybe weekend work. That's a big deal for certain production facilities. It certainly is a big deal for people. And I just want to highlight one of the realities that I faced is that normally the service of a dust collector is planned ahead of time. You say, okay, we're going to take our plant offline on a Wednesday or on a Saturday, or maybe we're going to bring in a special crew even on a Sunday, a Saturday, Sunday. And then the Saturday, Sunday arrives and the weather is bad, it's rainy, it's windy. Maybe in Texas it's hot and it's an incredibly hot, humid day, and you got guys servicing a dust collector at height, doing this work, as you can see in the corner there, outside on a hot, humid day or maybe a stormy day, and they've got to get it done. So downtime during servicing is a big deal to take into consideration when you're putting in a safe system. And then, of course, the modularity is important. Facilities change. You may want to move the equipment. Maybe you want a temporary facility. Keep it in mind that a dust collector is an expensive investment, and that you may, in the future, just want to plan that, what are the expansion possibilities, what's required. These are all things that I was dealing with personally. I was not from the dust collector business at all. And right now, even though I own and run a dust collector company, I still feel more like a missionary because I'm passionate about doing these things safely and practically and saving money, because I used to use dust collectors till 4 years ago. I used to purchase dust collectors, and now I'm in the business of trying to bring to the market just a much safer way of doing things. I sometimes have to remind myself that I'm actually not a user of dust collectors anymore, that I'm in the business of trying to promote smarter dust collectors.
Great, that makes sense. I think this is a great question from Mary. She'd like to know, how is the captured particulate disposed of?
I don't want to answer that question. Next. No, humor aside, that is handled. So typically the final resting place of a material that was captured out of the air could be as simple as a landfill where anything is dumped. It could be if it's cement dust or from drywall project or something like that, it could just be dumped like they would dump a vac truck. So it could be a landfill or something. So think of vacuum trucks, vac trucks. It would go to the same final resting place as that. If it's a more dangerous type of dust, maybe asbestos or hexavalent chrome or lead. We do a lot of lead cases where people are doing a rehabilitation of a facility where there's maybe lead paint involved. Those have to go to designated landfills or designated processors of that waste. Again, the nice thing with Blue Sky is the smart box is taken away to that processing facility as a sealed box. It is not opened up at the place of generation. So nobody's opening up a container and changing filters that may have asbestos all over them. The whole unit is taken away, sealed to the facility if it's hazardous waste. Pharmaceutical dust types are often incinerated. There are various things. And then, of course, there's recycling. If you're in a thermal spray company, often, or a grinding facility where you may be grinding titanium or grinding tungsten carbide, those dust types have high value. Thermal spray dusts mostly have high value. So they would go to a recycling company like Globe Metal or something like that, where, in fact, you get money for your dust. So the key thing with Blue Sky is that smart box, that dream maintenance, that box is handled away from the back of your building or away from the site. So for the coronavirus, let's say that's a coronavirus machine, and after a year, it needs a filter change. The key thing with Blue Sky is nobody is going to open up those disgusting filters at that site. It will simply, the smart box will be taken out. It'll be taken to a medical waste treatment facility for sterilization and treatment. And then new filters can be fitted at that site and be brought, recycled back. But nobody is going to open. There is no service technician in a suit ever doing the removal and the maintenance of that machine and its dust. It all gets taken away to a company, Stericycle, Clean Harbors, Waste Management, Republic Waste, whatever it may be, who as a career deal with waste. The waste handling is no longer done at your facility, that you end up with this kind of nonsense at the back of your building. Look at that, it's just incredible.
Right, that's a good point. Teresa would like to know, how does a facility, or can a facility, retrofit to an up to down airflow if it has a typical HVAC system?
Okay, so the bad news is it can't be retrofitted per se. What we are doing in all these spaces is that the HEPA filtration, the laminar flow system, is in parallel or is a separate system from the air conditioning system, because air conditioning systems are not designed to handle the type of airflows you need. They are not designed to handle contaminated filters very well. And so the last thing you actually want to do is suck a whole bunch of that garbage into your air conditioning system. What Blue Sky will do, it runs, 2 or 3 times harder than your air conditioner. It's continuously filtering the air, and it's because it's HEPA filters. The right size of HEPA filters needs a very powerful fan in order to draw the air through the filtration media. And HVAC systems do not have the correct power in their fans typically to enable HEPA filtration. So if somebody retrofits a HEPA filter into an HVAC system, something is not right, because the fan is not designed to suck through HEPA media, which is really, really dense. You need a much more powerful fan system. So what typically happens, if somebody puts a HEPA filter into an HVAC system, the airflow drops off. It's like running a very dirty filter inside an HVAC system. The airflow drops off, and you get very, very few room changes an hour, maybe 1 or 2 tops. So retrofitting an air conditioning system is complete nonsense. If somebody offers that, it's not correct. You need to bring in separate piping, a separate system, and that runs at much higher volumes and is dedicated to catching pathogens. You want to take out bacteria, fungus, and coronavirus in a separate machine. It's extremely dangerous, guys. You don't want to mix that up and spread it around the building through your air conditioning system. And just to mention as well, while I'm on this topic, air conditioning systems, and I think they're going to prove this more and more, I think are one of the biggest culprits why a city like New York has the coronavirus spreading quite so rapidly, even though most people are indoors most of the day. Air conditioning systems are actually from spreading flu and colds and viruses are responsible for a lot of sick building problems, including fungus and bacteria, of course. But I'm just sticking right now to the virus problem.
So that's an interesting and daunting thought. So we are at the top of the hour. We do still have some questions left, so I'll leave it up to you if you'd like to continue answering more questions, go past the hour, or if you'd just like to address these questions offline and directly with each individual.
I'm open to more questions. That's fine.
Okay, so I guess sort of a follow-up question to what you were just talking about. Michelle would like to know, do fans contribute to the spread of COVID if it's in the air?
Fans? Did you say fans?
Yes, fans.
Absolutely. If you have a fan or any left to right air movement. So here's a simple way to check a space. Have somebody light a cigarette or a cigar and watch the smoke. Cigarette smoke is an aerosol, and watch how it spreads. So if you put a fan in a room, you are essentially making sure that everybody in the room smells that cigar. So it is helping to drive the aerosols and distribute them evenly around the room. It's a little bit like stirring your coffee. It's a great stirring mechanism. Fans are used to distribute or move air. Well, when somebody is breathing out infected aerosol, you don't really want to move contaminated air. You want to move air so that you can remove contamination. And I actually used this analogy with my kids the other day. It's a little bit like when people used to smoke in their cars. If they kept their windows closed, everybody died in the car. I mean, it was just terrible. My parents smoked. It was, oh my goodness. So you open a window so that the smoke blows out, not blowing it in, but actually withdraws the air. So the idea with blue sky and laminar flow systems is bring filtered air in above people, have a gentle flow downwards, so that as you breathe out, you're following the natural convective path of particles. So large particles go straight to the ground within half a second or 1 second, they just go down. But the larger particles, which float around at mouth level and go a little bit up and a little bit down with Brownian motion, that the air is continuously moving downwards, downwards, downwards. Why is this important? Because you could be sitting in a chair in a doctor's waiting room and you could be infected. You may not even know it. You're breathing out, you're clearing your throat, maybe you're chatting with somebody. You are spewing out invisible aerosols. Every healthy person does, particularly in the winter. I believe the reason why these viruses are so seasonal is that in the winter, people breathe out more aerosols because of the dry air. Okay, so we're breathing out aerosols, and you get up, you go in to see the doctor, and the next person comes into the room and sits down in the chair where you were sitting. If there isn't good air ventilation and removal of contaminated air, you are now going to breathe in all the air that that prior person had breathed out. Again, the analogy of the smoker. Somebody sits in a chair smoking, gets up, leaves the room, and you walk into that space, you go, who's been smoking in here? It's disgusting. Somebody open a window. Well, in the winter, we don't open windows. And if there's an air conditioning system, it'll spread that cigarette smoke all over the place, and the whole building will start smelling.
That is great to keep in mind. Miguel has a question. First off, he says, great presentation, and you'd like to know how these type of actions can work with or be mixed with preventing explosions.
So the idea of doing environmental control is that you are continuously removing the air that is laden with dust particles. So the very, very fine particles actually never settle, you know, they can float for days, but there is a certain fraction that'll float for 1 or 2 hours. Pollen is an example of that, dust mites, you know, dust, hair piece. So the idea with environmental control is because you are continuously removing the air, by the way, your car is this way too, because you are continuously removing these fine particles from the air, they will not have time to settle. And if anybody's actually disturbing the dust and gets it airborne, it'll immediately be swept away as well. So what happens is that the overall loading of dust in the air of the working environment, let's say some guys are welding, it's continuously being drawn out, and that doesn't have time to settle in the roof beams, on top of light shields, wherever these dust types settle. So if you're working in a company that, say, got food processing, they're putting sugar on candies, or they've got flour because they put flour on cakes or baking or bread rolls, that fine dust, which you barely notice, is floating around, and you go back 6 months later, you go, wow, these lampshades are all covered, you know, everything is covered, the beams are covered. Those are all potentially explosion risks. And what happened, for instance, with Imperial Sugar is that they had a secondary event, you know, there was a fire or a small explosive event, which disturbed the dust, and then it ran down corridors, and it was an absolute catastrophe. You can Google it, it was just terrible. So the problem is that the dust begins in the air, settles out. I mean, you have it in your home, right? If you don't vacuum and dust for a month, go and touch surfaces, you have dust accumulation. But in certain industries, there's a lot of that. And so what the environmental control is doing is continuously removing it. I had the best analogy the other day was a fish tank. Your fish tank or your swimming pool is continuously having this filtration going, keeping the water beautiful, so that all that junk doesn't settle out over everything. It's being taken out of the water before it has time to agglomerate and settle out. Long answer, sorry.
No, that's great information. We have another question. Ganesh would like to know what kind of calibration is needed for all of the equipment involved, I guess, to upgrade or to move to your system.
So what we would simply do, and I'm using the word simply, is to determine the source of the dust so that we can try and create airflow. Airflow is the most critical aspect of installing a good dust collector system. I was inspecting a big factory in the Czech Republic recently, they huge production facility. They spent $3 million, 3 million euros, actually more, installing a dust collection system in their main halls. And they had put in quite nice dust collectors, but the way they were moving the air through the factory, they were trying to save money on ducting. And as a result, they had super clean areas and totally contaminated secondary areas. So the calibration of the system is basically with a good flow diagram of how to distribute the air suction points, very much like you do with an HVAC system, so that you can get good laminar flow throughout the facility. Plus, for local areas that may generate dust, you want to put local extraction so that you really keep it almost like in cells. This is particularly important with coronavirus, where we would put, let's say there's a dentist, we would bring the air in above the dentist and the patient, so that there's continual downflow. The dentist has a mask on, but there's continual downflow, keeping everything moving. So we'd focus the inlet air above the hazardous area and then have extraction at the perimeters. So we basically are doing a a very, very careful control of the airflow through the facility. I work closely with a company actually that does CFD modeling, 3D CFD modeling for critical spaces. But the first thing is calculating the total airflow and then how to distribute it within the facility. And that's how we calibrate it. And then in hindsight, testing it is quite easy with, smoke sources.
Right.
And I'm not encouraging anybody to smoke. So we'll just light a cigar and just have it there. No smoking.
Michelle has another question, and you have touched on this, but they would like to know, should most dust collectors be outside of the facility due to explosion concerns?
Yes and no. I would say if there is a higher than average risk of explosion, outside is always a benefit. So if you have the terrible situation of an explosion, absolutely outside is a good idea. But it's got to be engineered well as well, with explosion venting, things like that. I have some specific strategies that we use for blue sky to really mitigate, the after effects or the effects of a blast wave, a pressure wave, and the fire that ensues after that. There's a lot of strange stuff that goes on. Actually, there's not enough thinking going on there. My background, incidentally, is in explosions. My doctorate was in blast waves and explosions, so that's kind of a topic that I've spent way too much time thinking about. But it is possible to have a safe system inside. There would just be some special attention paid to how the system would pressure relieve in the event of an explosion, that it's contained and vents safely. If it's engineered properly, it can be inside or outside. Outside is just, you don't care as much, but you should always care regardless. Sorry, Michelle, that was not a great answer. I would say indoors, it can totally be engineered very, very safely. Outside I think a lot of dust collector implementation for explosion protection is a little bit sloppy outside, because there's a sense of if this baby blows, we've got the whole outside to absorb the shock, but it needs to be thought about.
Great. Stephen would like to know, what about collection systems for hexavalent chromium with regard to temporary outdoor blinds?
Temporary outdoor what, sorry?
Blinds.
Temporary outdoor lines.
Blinds.
Blinds. Not sure what he's referring to, temporary outdoor blinds. I'm not familiar with that term, blinds.
Stephen, if you're still here, feel free to reach out to us again. We can move on to the next question.
Okay, but all I can say is with hexavalent chrome, containment is an absolute requirement. Hexavalent chrome is really bad stuff. My entire reason for the invention of blue sky was hexavalent chrome. It is nasty stuff. It gets absorbed. It irritates human tissue. Aaron Brockovich. So dust collectors can really work, but they need to be well implemented. And as I said, blue sky is first and foremost a hazardous material dust collector, whether it be lead, hexavalent chrome, asbestos, coronavirus. That's really where it was born. But for silica and wood dust and everything, of course, it's a fabulous machine too. Let me have a look. Fabric building. Okay, like a fabric building. I see the question now.
Yeah.
Absolutely. I would do containment with a fabric building. Works wonderfully. That's how we did it on site ourselves. When we did a big panel job or something, where we were spraying big panels, we did it within a tent essentially, and we had extraction on that, and it worked like a charm. And then we kept the tent, because that tent fabric can then have hexavalent chrome on the surface. so you can't really then use it for the next wedding. But as a containment area, that is exactly how we did it. In fact, we had some situations where we built scaffold. We then topped the scaffold to create a tent. In other situations, we actually had a regular tent established so that we could then remove the hexavalent chrome and have zero emissions. Right. In winter, you can even bring the, if you use blue sky, you can bring the filtered air back into the tent and even have climate control going on inside the tent.
Right, that makes sense.
And coronavirus weddings, maybe we should put, sorry, it's not a time for humor, but you could even have for temporary hospitals, temporary examination rooms, maybe waiting rooms that you want to have outside a main facility. Putting blue sky into a tent with vertical flow is a perfect practical solution to large crowd handling. Obviously not a wedding, but certainly there are many reasons why you should have a tent with laminar flow in. I'm going to later on, if I can ever get anybody to actually, respond to me for elections and election seasons. I think the new normal should be that voting booths are tents with integrated laminar flow, so people can line up and then go into the tent, and that there is continual laminar flow so that one person is not contaminated by another person who has been in their spot and moved on. So social distancing is a crazy idea if you think about aerosols. We stand 6 feet apart in a line. The person in front of us moves forward by 6 feet, and then we step right into the space they were breathing. So exactly how social distancing prevents any aerosol contamination, it obviously doesn't. And I believe that is the reason why, despite enormous changes in behavior in terms of social distancing and hand washing, there is very little correlation to those methods, because the virus is probably spreading through simple breathing of aerosols. It does so in animals, and it certainly does that in people too.
Yeah, absolutely. Pradeep asked, what is the difference between negative and positive pressure, for example, in a hospital room?
Okay, so if you are in a situation, let's say you're doing eye surgery or something, that you want absolutely no air from the waiting room to end up in a critical zone, you would put that particular room under positive pressure, which means you are blowing more air into the room than you are sucking out with the machine, so that any leakage is always out of that room. So there is no way that some air that was in the waiting room ever ends up in the surgical area. Negative pressure is where you actually put the room under slightly negative pressure, like if you're doing an asbestos abatement or there is an infected person in a room, then you don't want the air in the room getting out into the surrounding rooms. So then you put the air under that room under more suction, and you keep the inflow a little bit restricted. So the room is so the leakage is into the room if it's an infected place or it has asbestos in it. Whereas if you're trying to keep bad stuff getting into a space, you want that room to be under positive pressure, keeping the junk out.
Right. So I have two more questions I'll ask and then we'll wrap it up. So the first one is from James. Can you speak a little more on the psychological effect in employees of having a cleaner, safer workplace?
Yes, I believe, and again, this is all touchy-feely, that when people come to work in an environment where the managers believe that having a clean work environment is important for the people and the product, it brings pride and a sense of wanting to be there. If your workspace is clean, the air smells good, there are no allergens floating around, you feel as though you are not breathing everybody else's stuff in, that will automatically promote a sense that I like being at work because I do not sneeze at work, or my allergies go down at work, or when I come home, my hair doesn't smell of the job, my clothes don't feel gritty. That promotes a sense of well-being. And usually it's surprising how much our well-being is determined by the air quality. We are so aware of water quality. We all drink bottled water. We are very careful about what we put into our water system. But frankly, our water and the quality of our water does not nearly have the impact that what we breathe and what we have on our skin floating around and how dirty surfaces are with dust. If you walk into a room that is very dusty, smelly, there's stuff floating around in the air, the instinct is to leave. But sometimes it's your job place. That psychological effect does impact people's productivity, their quality of work, their dedication to the job. And if they want to go home as quickly as possible, that is not the right workspace. So in the IT industry and Google and Apple and everything, they create beautiful workspaces. But if you're a welder or you work in a warehouse, nobody seems to care. Well, I think we should care.
Absolutely.
Because how those people feel at work really matters, and it will reach the bottom line of companies. They will get return on their investment, in my opinion. When I ran my company and we did this metal spraying, housekeeping was on top of the list, and the people who worked for me appreciated. They spent a lot of their lives at work, and they were proud. When they brought their wives and their kids around to work, they wanted to show them everywhere. And we were in a dirty job. We did sandblasting, we did spraying, but the place was clean, and the guys were proud, and they worked very, very hard.
Yeah, that's a pretty big indicator of a place that you want to be. It's clean and you're happy to be there and you're not looking to rush out the door. So I'm going to move on to the last question and just want to remind everybody that we will be sending a copy of the recorded webinar, including the question and answers, to everyone after this webinar is done. So if you did need to leave early, that's fine. You will be getting a copy of this. So the last question, and I can already take a guess at how you're going to answer this one, but Partha would like to know how airborne hazards can be eliminated by investing the lowest possible money in the construction industry.
Construction industry is really interesting. Okay, so of course, construction goes into suppression. So in certain areas where they cut concrete and that, they can use water systems. I'm not a big fan of water suppression because it's only temporary suppression. The runoff dries, the dust is around anyway. So currently in the construction industry, a lot is done with water suppression. So it's source capture, where you want to try and capture as much of the larger dust as possible at source. And you do that normally with a hood and an extractor system. They do that in the woodworking industry, obviously on cutting machines. There's been a big drive to source capture. Source capture is an absolute requirement because you don't want to overload the systems. But source capture also brings a danger. A lot of people feel that if you have source capture, you have now done the safety work because you can see it's much cleaner than it was. That is complete nonsense. The dangerous dust is still floating around. It doesn't get caught very efficiently because it drifts. It's highly dispersed. So the first step is source capture. The second thing is environmental control by having enclosures and putting dust collectors in place. If it's enclosed space, and with silica, you cannot, with the new silica regulations around, and they're going to go global, you cannot put these ultra fine dusts into the air anymore because they do get breathed in by all living creatures, and they have a slow but definite effect on reducing lung capacity when you are older. A lot of the reasons why people struggle with breathing and what seems to be fitness issues is because their lung capacity has dropped 5% 10% during the course of their lives because they are breathing in things like silica. These are proven effects. Most people don't think about 10% as being a big deal, but when you develop infections later in life, like pneumonia, like bronchitis, it can actually be devastating for you if you have reduced lung capacity. One of the guys who works with me, James Pruitt, his dad worked in the construction industry, and as a not very old man, he developed severe fibrosis of his lungs, progressive, and unfortunately passed away from it. But it was very, very miserable. I cannot begin to tell you that when you lose your lung function, you can't breathe and struggling to breathe. And it's all created, smokers know this. If you're smoking from your 20s, you will pay the price later in your life for the accumulation of effects. And it's lung tissue scarring and, of course, potentially cancer or emphysema or serous fibrosis type diseases. Take care. It's, people who work hard, classic blue collar type jobs, when they get older, it matters how well they feel.
Absolutely. Your lungs are an important part of your body, and you got to make sure that they stay healthy. So with that, I'd like to give you an opportunity to say any parting words to the audience.
Yes, I would say that environmental controls, cleaning the air, you're doing a service to yourself and your family. You are doing a service to the facility where you work. And it's a long-term service. It is very, very hard to justify. Very, very few people will make the investment to clean the air. We will buy bottled water and we will try and keep the trash sorted so that we don't pollute the environment with plastic bottles. But when it comes to the stuff we breathe, we're not ready to spend money typically. And I understand that too, because I'm also a person who breathes air that's, every day, and I need to spend money to clean it. But the cleaning of air, and then the second part, which is where my passion comes in, is to invest in equipment where the maintenance of that equipment, which has captured all that dust, all those dangerous particles, they may be flu viruses, they may be, stuff that you really, really would never want your kids to ever touch, ever, that you invest in the kind of technology. And Blue Sky is, obviously, this is my entire focus, is not only to have a wonderful mousetrap, but to really care about what happens to the dust once you've captured it, how it's handled, how the machine is maintained, to keep it functioning well over time, and essentially just be intrinsically safe. Intrinsic safety is so critical when you decide what kind of machine you're going to implement to keep your air safe.
Absolutely. Well, on behalf of Blue Sky Global and Safeopedia, we'd like to thank everyone for attending today's webinar. Thanks, take care, and stay safe.